right, we're going to start we are going to start the sketchmark on stage 2 for photosynthesis. First thing that I want to go back over is our equation. Somebody give me our photosynthesis equation.
6H2O.
Okay, 6H2O.
Carbon dioxide, CO2.
Carbon dioxide, 6CO2. Yield. And we add sunlight in.
Glucose.
Glucose. What's glucose?
6O2.
H12.
What?
6O2.
One of you.
6O2.
Rachika.
6O2
Okay, so 602, you're going with for the oxygen first.
plus C6 H12 06.
0?
No, 06.
Oh, 6. O is for oxygen, no 0. Alright, which ones did we use in stage 1? Which ones did we address in stage 1?
H12.
We talked about H2O, talked about O2, and sunlight, right? So that means that carbon dioxide and glucose are what we're going to be addressing this time around. Everybody's good with that?
Yes. Yep.
All right, so stage 2. Stage 1 had names like light reactions, light-dependent reactions. Stage 2 is going to have the opposite of stage 1. So there are going to be dark reactions, light-independent reactions. No light is necessary. In addition, stage 2 has an extra name called the Calvin cycle. I'm sure you guys can kind of figure out that that would be because of who named it or who created and discovered it. So, when we talk about the dark reactions, all right, it's because there's no sunlight needed. Dark reactions will still occur when there's sun. All right, so don't think that this can't happen if there is sunlight. It's still going to take place when there is sunlight. It can just continue after the sun has set. So after the sun has set, the plant can continue to produce its glucose for survival.
Does it work with plant and water, like under?
Yep. Well, depends on how deep you go. If you go all the way to the bottom, there is no sunlight, which means there's no photosynthesis at all, which means this doesn't apply. Chemosynthesis.
Whatever it's called.
Chemosynthesis is what happens down there, the chemicals. But, so, this will take place, tide pools, all right, shallow waters, this will still happen. Algae, still going to take place. So, like I said, Calvin cycle, named after Melvin Calvin. He's the guy that kind of described and discovered this entire process. All right.
Wait, photosynthesis or like the stage 2?
Stage 2. Now, just the Calvin cycle. Cycle. Repeats. Implies repetition. It implies it goes round and round and round and round, right? So, stage 1 took place in the thylakoids, in each of our little pimentos, right? Stage 2 is going to take place in the stroma. In all of that extra space, what's coming from stage 1 into stage 2? ATP and NADPH, the energy, right? That chemical energy, that temporary energy is what comes out of stage 1. We're moving it into stage 2. Right? So, just like I said, in the stroma, in that extra space, the stroma is kind of like the cytoplasm, but of the chloroplast. All right, so is red working okay with you guys? Sometimes it's tough to pick what color I need to use. So I'm just going to write a little equation to kind of put a gap into the photosynthesis equation, kind of break it up separately. You're putting ATP in, you guys said, and NADPH. These two were the stage 1 products, right? You're also putting in CO2, we already established, and what you're getting out is the glucose. So this can kind of be like a second, right, like a sub-reaction within the entire reaction if we wanted to break it up separately. So we need to put in the energy to take the carbon dioxide, rebuild it into the glucose molecule, right? And the whole point is to make the glucose, make the food, right? Photosynthesis is making food, not energy. Smile, nod your heads. Yes. Yes.
Yep.
All right, so 1, 2, 3, 4, 5, 6. 6 carbon dioxide's going in, 1 glucose coming out. Unfortunately, it's not that simple. I wish that this was what you guys needed to worry about, and I wish that this was all we needed to talk about. But we already said that we also have ATP and NADPH coming into the stroma, right? And that helps create our food. Yes. This, yeah, is more like what you need to know. I promise it's not nearly as bad as it looks. Everybody tends to look at it, freak out. It's really not that bad.